For our second experiment, we're going to be working with pressure and wind. Pressure and wind are quantities that are fundamental to meteorology. So if you look at, for example, the television news programs at night, they'll give you actual pressure measurements, they'll talk about the wind. And wind is something that we feel on a day-to-day basis, but we're going to try to get a handle on this quantity pressure. And pressure is really a sense of how much the air is sort of pressing around you. And in meteorology we use a tool called a barometer to measure pressure. So in this lab we're going to be working with a very simple kind of barometer. I've got one here. And what this is just a piece of plastic tube that's nailed, in this case, or attached to a board, and then there's some water with some green food coloring in there, and the water level is right there. And what we're going to do is we're going to actually try to measure the pressure inside of a balloon. Now when I blow up a balloon like this, okay, the air inside of the balloon is at higher pressure than the air outside of the balloon. How do we know this? Well, wind, as it arises in the atmosphere, is a response to differences in pressure. So wind is just air moving around. So if I let go of this end of the balloon like so, air rushes out of the balloon. It's moving air, so it has wind, and because of that then we can say that the air inside of the balloon is at higher pressure. So what we're going to be doing is we're going to be using this really simple barometer to measure differences in pressure, specifically the difference in the pressure between what's inside the balloon and what's outside. This barometer, both ends are open to the air, and if you look right now, the two water levels are exactly equal to each other. So we put a balloon on the end of this and something's going to happen, and that's what we're trying to figure out. Alright, so we're going to measure the pressure inside of three different balloons. We have this little balloon, which is really a water balloon kind of balloon, so it's a really small balloon. We have a sort of intermediate sized balloon, and then we have a large balloon. So we want to think about sort of one question is, just by guessing, in which balloon do you think the pressure is going to be largest? The pressure difference between the balloon and the air outside. Is it going to be the little balloon, the medium balloon, or the large balloon? So what I want to do first here is mark my 0 water level. So this is where everything is at rest. In other words, if the pressure in the top of the two tubes is equal, and then I'm going to go ahead and hook up we'll start with a large size balloon first, okay? So here we go. And I'm going to blow these balloons up so they're about the same size. Alright, so here's our large balloon, which has a hole in it. Disasters happening. Small disasters. Here's our large balloon. And again, it's about the size of my hand. Okay, and I'm going to put it on top here of this and let go. And look at what happens. Okay, so pan down. Alright, so we see that the water level, in this case, has become displaced. That the water in the tube that's open to the air is way up here, and the water in the tube that's not exposed to the air, that's touched with the balloon, is way down here. So what's happened is the balloon is pushing harder on this column of water. It's pushing that column of water down, which in turn pushes that column of water up. So what I'm going to do is I'm going to put a mark down here, and we'll come back and measure that a little bit later. Okay, so that's the big balloon. And we let go, and magically the water columns bounce back to where they started. Okay, so this is the medium-sized balloon. Don't chase around. I'll come to you. Okay, so we're going to attach that to the top of our thing. And you see that we've gone even higher. In fact, we're off of this white paper scale here that we have for the rest. So I'm going to go ahead and mark my wood there. So that's my medium-sized balloon there. So what this is telling us, of course, is that the medium-sized balloon is pushing the water down further than the large-sized balloon was. Okay, so we'll go to that. And we'll get our small balloon. Here we go. So again, everything returned to normal. Now we're going to blow up our little balloon. Here it comes. Okay, so there's our little balloon, and again I blew it up to about the same size. And hook that up to the top of my tube, and wowzers. There's something for you. Okay, we see that that's pushed the water all the way down here in that situation. So down here we have the large balloon, we have the medium-sized balloon, and then we have the small balloon. So first question is, of course, well, which one has the highest pressure inside? Well, again, the pressure is going to be sort of proportional to the amount that things are being pushed here, downward. Okay? So what I'm going to do is I'm going to take this balloon off there before we have a mess. And then we're going to go ahead and measure how much this displacement was. Okay, so I've got my ruler here. Okay, and I'm going to measure this in centimeters actually. So, okay, so the large size balloon displaced my water column about 10 centimeters. 10 centimeters, okay? My medium size balloon, and that mark is right down here, displaced my water column about 15 centimeters. 15 centimeters. And I'm going to go from my excuse me, my large size balloon mark to downward to measure where I got here. So this one was 10 centimeters, and I'm going to add to that something. There's down here at the bottom now is where my small balloon was, and we see that's 10 centimeters plus 14 centimeters. So this small balloon displaced the water column by a total of 24 centimeters. Now it's those numbers that you want to go ahead and use in your lab manual in order to do part 1. We'll be back to do part 2 in just a moment. Alright, so for the second part of the lab, what we're going to be doing is trying to measure the wind speed inside of the balloon. Now measuring the wind speed is a little bit more complicated than the pressure. Pressure doesn't go anywhere. You know, we attach the balloon in the prior example to the top of our tube there, and it just stood there, so we had a lot of time to measure things. Measuring wind out of a balloon in particular is a lot more difficult. Measuring wind out in the real atmosphere isn't so bad. You have a device called an anemometer, and you may have seen one of these along the road or on top of the Kunkel Center at UWM there, or other places where it's kind of like a little windmill and it spins, and by the rate of the spin you can tell how fast the wind is blowing. Well, we don't have that luxury because the air is going to rush out of our balloon and away we're going to go. So we're going to give it a try here. So here's our large balloon. I'm going to start with that one, and so what we have here is a protractor used to measure angles. We have a ping pong ball on some string, and we're going to measure the angle that our balloon wind displaces this protractor, and we're going to do it a couple of times just so that we get a reasonable idea of how things actually work. So here we go. I'm going to blow my balloon up to its standard size. Okay, and then I'm going to release the air on the ping pong ball and try to get a sense of how fast the wind is blowing based on how large an angle the ping pong ball makes with vertical, in this case 90 degrees for our protractor. Okay, here we go. 1, 2, 3, go! Okay, that looked like it went to about 60 degrees, so that would be a 30-degree displacement. We'll try that again to see. Okay, so one more time. Here we go. And might have made it all the way to 50 that time. Okay, and one more time. Okay, so that would have been a 40-degree displacement. If it goes from 90 to 50, that's a 40-degree displacement. Here we go, one more time here. That one was about 60 as well. So somewhere between 30 degrees from 90 to 60 and 40 degrees between 90 and 50 is the displacement for the large balloon. Okay, let's try the medium-sized balloon now. Here we go. Okay, and 1, 2, 3, here we go. Ooh, that one made it all the way up to 50. Okay, one more time. Calm things down here. Okay, here we go again. Right on 90, and here we go. Yep, up to 50 again. So, okay, so that one appears to have gone from 90 to 50 pretty consistently. So that's about 40 degrees of displacement there. All right, now we're going to get the small balloon, our third and final balloon here. Remember, this was the one that had the largest pressure in it. Okay, so here we are. Small balloon is blown up. All right, and here we go. 1, 2, 3. Okay, that wasn't a very good one. I'm going to try that one again. You can see that this is not a particularly accurate or good way to measure the wind, but it is one way to try to measure the wind. If you held this outside, for example, and you could pay attention to how much it's swinging back and forth through time, you might be able to come up with a little better average of what the wind is actually doing. We'll give it one more shot here. Here we go, starting at 90, and That one made it up to about 50 as well. Okay, and one more time, we'll stop things and try it once more. Here we go. 1, 2, 3, and... Oh, that one made it up to 40. Oh, I'm trying one more time. So that was from 90 to 40, so that was a 50-degree displacement there. One more time with the little balloon. See if we can get it back up to 40-ish or so. And here we go. 1, 2, 3. Yeah, it went up to 40 again about. Alright, so that completes our things for Lab 2. Our large balloon went from 90 to 60 or 90 to 50, so that would have been a 30 or 40-degree displacement. Our medium-sized balloon went from 90 to 50, so that would have been about a 40-degree displacement. And our little balloon went from 90 to about 40, so about a 50-degree displacement. And you can use those numbers then in your lab manual for your write-up. All right.